Atoms interact with each other in order to form molecules and compounds, and the interactions that are created to form molecules and compounds are called chemical bonds. We're going to talk about a few different types of chemical bonds and why the atoms of these different elements form these types of bonds. Last lecture, I showed you what sodium and chlorine look like at room temperature and pressure. We have a metal, hard metal in sodium. Chlorine is a toxic gas at room temperature and pressure. But when atoms of these two elements combine, they form sodium chloride, a salt, or in this case, table salt. And so the properties of the individual elements are very different from the properties of the compounds and molecules that are made from those elements. This periodic table is a representation of where the electrons are in the shells that are surrounding the nucleus of the atoms. So in this case, we're not looking at the atomic number or the atomic weight. We're looking at the position of the electrons in different electron shells. And remember that the first shell can hold 2 electrons. If there are 2, they are paired. Then the shells outside of the first shell all hold 8. And if there were 4 electrons to position in the outermost shell, like in the case of carbon, then we'd see 1, 2, 3, 4 electrons all unpaired. And then if there were more electrons to fill into this outer shell, we'd start giving our 4 positions pairs. An atom whose outer electron shell, whether it's the second, the third, or the first, second, or the third, if the electron shell is not full, it tends to interact with other atoms, and it will share, gain, or lose electrons in order to fill that outermost shell. And those tendencies, those interactions, are called the chemical bonds. We call the electrons that participate in chemical bonds valence electrons, and the valence number then is the number of bonds that the atom could form, because it's the number of electrons needed to fill up the energy shell. 2 types of bonds we're going to talk about. First, I'm going to talk about a covalent bond, where atoms don't transfer electrons, they don't gain or lose, but they share electrons between them. And then I'll talk about ionic bonds, the transfer of an electron between atoms. And the transfer of the negatively charged electron will cause the 2 now charged atoms to interact with each other and form an ionic bond. In covalent bonds, atoms share 2 or more electrons to fill the outermost shell. So here we have 2 atoms of hydrogen, and we don't see the electrons because remember they're kind of in a cloud around the nucleus. We have a proton inside of the nucleus, and the atomic number of hydrogen is 1, which means that it has 1 proton and 1 electron. As these 2 atoms approach each other, the 1 electron of each atom is also attracted to the proton in the nucleus of the other. So what will happen is the 2 electrons will become shared in a covalent bond, and now the outermost shell, which in this case is the very first shell, is filled with 2 electrons. Let me show you in a different kind of picture. This is the molecular oxygen, kind of oxygen we find in the air, is called O2. And oxygen atoms form O2 in order to fill up their outermost shell. Both of these atoms of oxygen require 2 more valence electrons. So these 2 atoms of oxygen can actually share each other's electrons so that now the outermost shell is filled with 8. 1, 2, 3, 4, 5, 6, 7, 8, and that's the same for this atom as well. In this case, the 2 atoms are sharing 2 pairs of electrons, and so we call this a double covalent bond. Now within covalent bonds, there are 2 types. There's a nonpolar covalent bond where the electrons are shared equally, so that's like the case here. They're shared an equal distance from the nucleus of each atom. But a polar covalent bond is one where electrons are shared unequally between atoms. And that is because the atoms have unequal values for something called electronegativity. That's the tendency of an atom to pull shared electrons closer to its nucleus. So sometimes, like if these are of two different elements, the electrons are going to be shared unevenly. They're going to be closer to one nucleus than the other. Electronegativity of an element or an atom of an element is a balance between how big the nucleus is, so how much positive charge there is, and also how far away the electrons are from that nucleus. There's actually values associated with each type of element, and I don't need you, of course, to remember the electronegativity chart. I just want to show you that, for example, if an atom of carbon was sharing with an atom of oxygen, the electronegativity of carbon is 2.6, which is relatively low. The electronegativity of oxygen is much higher at 3.4. And so if they were sharing electrons, oxygen would be pulling the electrons closer to itself. And that would be a polar covalent bond. Now, if carbon and hydrogen were sharing with each other, their electronegativities are pretty similar. So when carbon and hydrogen share with each other, the electrons are found kind of in the middle, and that's a nonpolar covalent bond. The reason why they're called nonpolar and polar is because of this word right here. You guys are familiar with poles like North and South Pole. This type of bond, where they're not sharing electrons evenly, creates poles where there is a slightly more negative side and a slightly more positive side. So this is actually a molecule of water. 2 hydrogen atoms are sharing with 1 oxygen atom. And if you go back to the electronegativities, the electronegativity of oxygen is much, much higher than that of hydrogen. Dark orange versus kind of a darker yellow. So oxygen is tugging on those shared electrons closer to itself than hydrogen, and electrons are negatively charged. So this oxygen atom is going to have a slight negative charge, while the hydrogen atom has a slight positive charge. And this molecule is polar because these 2 polar covalent bonds give this end a slightly negative charge and this end a slightly positive charge. So here is a look at water, oxygen sharing its electrons with hydrogen's electrons. Everybody's outermost shell is filled, and the bond between them is polar, the bond between these atoms. Something like oxygen, where the electrons are shared evenly, this molecule would be considered nonpolar. And there are a variety of ways to look at these things. We've got the molecular formula, how the electrons are shared, the structural formula, where this line here represents a covalent bond, and then these space filling models. And what I do want you to remember when it comes to nonpolar and polar bonds is that whenever oxygen is sharing with any of the other atoms that we're going to talk about, it is sharing in a polar way because oxygen has this really high electronegativity. Oxygen will share with carbon, it'll share with hydrogen. And when oxygen shares with those, then it's always pulling the electrons closer. Now, carbon and hydrogen, remember their electronegativities were really similar. So whenever carbon is sharing with hydrogen, it is a nonpolar situation, like when 2 atoms of the same type are sharing with each other. Of course, they're going to have the same electronegativity, so it's totally nonpolar. Carbon and hydrogen have similar enough electronegativities that this is nonpolar. And that also means that there's no partial positive and negative charge. This is kind of a neutral molecule when it's nonpolar. And this has that slight positive and slight negative end.